Hi everyone. Welcome back to my YouTube channel. I'm your host Vishal, and this is going to be a Snowflake Zero to Hero series where we are going to take you from a basic to expert level of knowledge into the Snowflake. In my previous videos, I have covered the fundamental of the Snowflake, the pricing, and the UI overview. In the last video, when I was explaining about the UI, I did not explain about the Snowflake virtual warehouses. So this is going to be a detailed session on the Snowflake virtual warehouses. In this video, we are going to understand how the Snowflake virtual warehouse sizes, like basically the admin is going to give this, decide the size of a virtual warehouse, how the pricing will be calculated, what are the other parameters which is going to help you in your longer way or in your basically like in your day-to-day activities. What are the like how the Snowflake virtual warehouse handle the large load, how it provide you the scalability, everything we will be understanding here. Before that, let me just take you to this document. What all you understand about the warehouse? In a normal term, this warehouse is basically a central repository where we are keeping our data, right? You all have been coming from a data warehouse background, you know it, it's a central repository, it's kind of my Teradata, it's Oracle, and I'm keeping my data over there, and it is like I'm extracting from heterogeneous sources, and then further it is being used by the reporting people or data mining and all other purposes. But here into the Snowflake, whenever we are going to speak about the warehouse, we are not speaking about like a central repository. We are talking about the machine. We are talking about the compute power, which is going to help you to load the data, unload the data, and query the data. Understand these three main purposes: query the data, load the data, and unload the data. Load the data where? Into the Snowflake storage layer. Unload the data outside of the Snowflake to the cloud storage like a GCP, AWS S3, or Azure ADLS. Okay, so this here we get the different size of the virtual warehouses. If I come to my Snowflake window here, if you go to the home page here, in the home page section, you need to come to the admin. In the admin, you see the warehouse sections. Okay, this warehouse section, get it over here, and you will be seeing all your warehouses. Okay, before going that, let me just repeat whatever we have just going to give you one liner. So this warehouse provide you the required resources such as CPU, memory, and temporary storage. So if you wanted to perform any of the operations, if I wanted to load the data from outside into the Snowflake, I would be requiring this virtual warehouse. If I wanted to perform DML operations such as delete, insert, update, or merge, I would be requiring a virtual warehouse. If I wanted to load the data, copy into location, copy into table, for that also I would be requiring a virtual warehouse. But one thing which I did not mention here, I mentioned the DML copy into location, but what about the DDL statements, right? If I'm going to write a create table, the customer, and then if I run it, would it be requiring active warehouse? Now, so all the detail statement does not require an active warehouse. However, this is great. This error is showing because we don't have any active sessions. So for that, I'm going to select my YouTube learning, and here I can simply select the raw data. Now, if I'm going to run it, let's just see it quickly. Right now, how you will be checking your virtual warehouse is active or not? You can see that if this is green, and even when you're going to hover on top of this color, you will be seeing this is the started. But I can just quickly suspend this warehouse. So from status to suspended. Okay, now you see it turned gray and it is suspended. So if it would be requiring an active warehouse, it should automatically turn green. And how it automatically turn green, we will be understanding in next couple of minutes. So now look at it. If I'm going to create table, this is sleeping, right? There is no change in the position. So for the DDL statements, there is no need of an active warehouse. Next thing, if I'm going to write some select clause, select statement, I mentioned here executing select statement that required compute resources. What does it mean? I even mentioned not all select statement require an active warehouses. So just focus on this part where I'm writing select count star from, I'm selecting from a sample data. Look at this. When I executed this one, it took only 55 seconds to give me the count and my warehouse is still not active. It is sleeping. Okay, so it is not mandatory that for all the select statement you would be requiring an active warehouse. Okay, so have this clarity in your mind. The detail statement does not require the warehouse, and also not the select statement where we are selecting a metadata. Those also not require an active warehouse. But what definitely will be requiring a warehouse when we are performing the delete, insert, update, merge, copy into table, copy into location, select those complex query. There you will be requiring this warehouse. Okay, we'll see that you will be like getting clarity in the few like in next couple of minutes. Now the next thing is how I'm going to decide the size of the warehouse. What are the other parameters we have it? If I'm going to write any query, let's suppose there is a requirement that I need to select my data. Okay, if I need to select from any random table, I'm selecting from here only. This time I'm writing the line item, but I'm writing select star and I'm writing limit 100. Now you see when I just executed a select statement and you see this warehouse turned green and it is started. In fact, if you will look into the query details, there is a three colors. One is the compilation, which basically cloud service layer checked everything, whether the code is working fine, whether we have access, means the particular role has access of this table or not. Second, it checked for the query result cache, the result into in its own memory. If the data could not find, then it came to the cloud service layer, came to this compute warehouse and asked him, "Bhai, wake up because I have something for you." And then he woke up and then executed the query. He got the data from the storage layer. This is how the query execution flow. Okay, now we can see that. But if I'm going to write the same statement one more time, then how much time it's gonna take? It took only 67 milliseconds because that is basically the result cache came into the picture. And for this query, I did not require an active warehouses. Okay, so the select statement also, if I'm writing some complex query for those select statement also, I may not be requiring 100% of the time active warehouse. Although it is like a spin up, it is already there, but it will take some time to go back into the sleeping position. Okay, now what is this result cache? We will be discussing in the next video. Okay, why it took only 67 milliseconds. Don't worry about that. Okay, now let's come to the admin portal here into the home page. I'm sure you will be having your trial account, so that is why you can see this. You can see all the options here. If you are going to use any custom defined role, you won't be seeing some options here depending on your permissions. Okay, now let's come to the warehouse section. In this, I see the three warehouses, but I will be creating a new warehouse from the scratch. So if I click on this plus warehouse, and there, the first thing I need to give a warehouse name. Let's say this is going to be my YouTube learning warehouse. Now what? This is just a name. It's very simple. Anyone can do that. Next is the head comment. This is just for your purpose, like for your audit purpose or for your tracking purpose. Why I have created this warehouse? If let's suppose I'm coming back to my account after 5 months and there are 20 or 30 warehouses where I have given the permission to multiple users to create it, and I wanted to know why this person has created this warehouse. So at least I'm just getting adding one comment. I'm creating this warehouse to use for my YouTube videos. That's fine. I'll get to know. So this is just a comment, right? But now let's head to the next settings. First one is the type. So I do have a two type of warehouses here. One is standard and second is the Snowpark optimized. For our training, we're gonna use the standard only, and in fact 70 to 80% of the time, because this Snowflake majorly gonna use for your data warehousing purpose, for your data engineering purpose, the standard will be perfectly fine for you. However, if you want to perform some machine learning activities and some machine learning work, then the Snowpark Optimize is best for you, because it gives you a larger memory and the larger cache, which is definitely going to help you in the performance. But this is completely fine. We are just not going to not going to perform any machine learning or something like in this particular learning. We will be focusing on majorly into the data engineering and data warehousing side. So I'm going to use the standard one. Now, next one we have is the size. So in this size, like you see, it varies from extra small to 6XL. Like here, 6XL is not showing up, but my warehouses, Snowflake Virtual Warehouses sizes varies from extra small to 6XL. You will see here in the documentation, the warehouses is basically varies from extra small to 6XL. This document is also older, so that's why you're not seeing over here. Okay, now this extra small is taking 1 credit per hour, and then 5XL is taking 256 credit per hour, and 6XL will be taking a 512 credit per hour. That means I need to know the perfect size. I need to choose a right size of the warehouse for my load. Otherwise, I will be paying a huge bill to the Snowflake. It's simple. We cannot directly go to the any hotel, or we just order anything without checking the menu, right? First, we take a look at the menu, and then only we order something. So this 1 credit per hour means if I'm continuously going to use this warehouse for next 1 hour, I will be paying 1 credit. That means I will be paying $3 to the Snowflake. We have discussed about the Snowflake pricing in my previous videos. So please watch this out. And if you have any confusion, feel free to drop any comment. I will be happy to answer you. Okay, similarly, if I go for small, medium, large, you just need to multiply by 3. But what exactly it is happening under the background? So this, if I'm saying extra small 1 credit or small 2 credit, that is basically a cluster. And inside that, we have number of servers. So my extra small holds only 1 server, small holds 2 server, medium 4 server, and similarly 5XL is going to have 256 servers. Now, just consider, replace the server term with the person and this warehouse term with the team. So extra small is basically 1 team which is having only 1 people. Then there is a medium team which is having 4 people, and next to large which is having 16 people, and those are of same configuration. Under the hood, although you will not be finding any white paper, but under the hood, it is going to have a same configuration like a 4-core processor and 8 thread. So if there is an extra large team where we have a 16 folks, then definitely that team is going to deliver one work very quickly comparatively the extra smaller small team. Yep, no doubt in this. So in this, just take a look of it. This is my extra small warehouse, extra small, which is having 1 credit. This medium, 1 cluster of 4 server. Look at it. This, consider this is as a team. There are 4 people standing. In large, we have 8 people. In extra large, we have 16 people. Similarly, you will be seeing that, okay, it is a cluster, but the 4 server, 8 server, 16 server. And if I'm using a large, because extra small is having only 1 people, and I told you that it is going to have a same configuration, consider that you are hiring 5 people from the T's, or 5 people from a college, and you only give to, going to pay them a 3.2. Like everyone will be getting a same package. You cannot just give someone as 5 or someone 10, right? So similarly here, every server is of the same configuration. So they are just going to consume the same amount of credit, because in extra small, there is only 1 server. So if you're going to keep running for 1 hour, it will be 1 credit. Similarly, for the 2XL, there will be 32 servers. So it is going to generate 32 credits per hour. And then the final bill will come into like 32 into 3 or 16 into 3, like that. Clear? So the very first thing you need to keep in your mind that you will always and always choose this your warehouse size. You will be starting with the smallest as possible, and then you will be performing the query depending on the load, depending on the query performance. You will be increasing the size of the warehouse. Next, we have that advanced option. So what does it mean of auto resume and auto suspend? So auto resume, it's automatically resume the warehouse whenever I'm going to execute any statement. And auto suspend, it's going to suspend the warehouse just after 5 minutes of inactivity. Now let's understand into a very simple word. Okay, just suppose I am actually living in a normal house which is not a IoT enabled. I entered in my house at 9 a.m. in the morning. I got the call from my friend that Bhai Aja, let's go and have some party and all. Okay, but because I entered into my house, I'm living in Delhi. It's totally it's a very hot, so I turn the fan, I turn on the television, I turn on the AC, and then I'm enjoying it. It been around 5 to 10 minutes, and then I got the call from my friend, bhai aja come to the CP, and then we'll go for a party and all. Okay, I went there, but one thing, I forgot to turn off all these electronics appliances. I came back to my home at 9 p.m. in the night. From 9 a.m. to 9 p.m., everything was on. So it is going to generate some units. Ultimately, what? Not only I'm just going to pay the bill into the bar, but I will be paying the bill of those electronics appliances for 12 hours where there was no users. No one was there. No one was actually like using those services, but ultimately I had to pay. Okay, so this is a disadvantage of not having an IoT enabled houses, or you can say like not a sensor enabled, or you can say this is the basically consequences of my being a careless. Now, consider after 1 year, I shifted in another house which is completely a sensor based. Now, as soon as I entered in my house, it my senses senses that okay there is a person in the room, and it automatically turn on the fan, AC, and television. Now again I got the call from the same friend, let's come for a party, and I again forgot to switch it. I switch off it, and I immediately go away. But there is a sensor. It senses that after the 5 minute of inactivity, if there is a no person into the room, immediately after 5 minutes, it is going to turn off all the electronics appliances. And in this case, I will be only and only paying for 5 minutes. So that is the same way here. If I'm going to choose the auto suspend and I'm not going to write any query, then just after 5 minutes, it is going to suspend the warehouse, and which is going to save a bill from my pocket. Sounds good? If you still have any doubt, you can just drop your comments. Okay. Now, next we have is the multi-cluster warehouse. This multi-cluster warehouse is required when we are dealing with a large number of queries, or we have an extra number of users. In that time, we will be going for multi-cluster warehouse. But how? We cannot simply go, okay, no, my max cluster count should be 1, 2, 3, 4. No, I will be understanding the load. I will be checking my query history, will be understanding the warehouse load, and then I will be deciding it. But what exactly this multi-cluster warehouse? Okay, consider one example. Okay, like if I am writing some queries and I executed like a 4 or 5 queries, my one cluster, that one person, because I took an extra small, that guy is actually busy in solving those queries. Now there is a one reporting guy who also triggered some queries from Tableau or Power BI. Then they will be going to the queue. Why? Because this warehouse, that person is actually solving those initial queries, and that is going to take some time. So till that point, though Tableau and Power BI guy has to wait for their queries needs to be performed until this gets some resources. What will happen? Those query will go into the queued mode, and then ultimately it is going to impact the performance, right? So in this case, what if as soon as there are some queries are waiting, we want the Snowflake need to take care it by own by adding some other compute machines. So here, this is going to be like kind of a multi-cluster. So if it is there, like if any queries are waiting into the queued mode, it will automatically add a new cluster, and you can set the maximum value up to 10. This is totally up to you. Now, one of the good thing about is that if I'm going to select this as a 4 or 5, but there are very less queries are being executed, then I will not be paying for all 5 cluster. I will be only and only paying for that cluster which is in active mode. Got it? Now, coming to the next question, what is the meaning of the scaling policies? If I took a 1, this next is the 5 cluster, but what this is standard and economy? That means if my queries are being executed on the first cluster and the next query is coming to it, initially it will wait for, if my policy is set to standard, initially it is going to wait for 20 seconds. So the next cluster will wait for 20 seconds to check whether this can actually handle that load or not. If it not, then the second cluster will come in the picture and will be solving those query. So in standard, which is basically best for the performance, and it only wait for 20 seconds before spin up the new cluster. But the economy, it waited for 6 minutes and then spin up the new cluster. So economy is when we wanted to save credits. Okay, so multi-cluster warehouse is nothing but a horizontal scaling which is going to add the new cluster. And also in the Snowflake, we know this process as a scale out. But the changing the size of the warehouse from extra small to medium or medium to large, that known as scale up, which we call it as a vertical scaling. Okay, so this is how we're going to create our warehouse, and then there is a one property which is query acceleration. I will be discussing into the later when we will be talking about the performance optimization. Okay, now I'll just simply click on create warehouse. Now you see, okay, there is a 5 cluster is one of 5 cluster is active. Total 5 cluster are there, but only one cluster is active. So for this time being, I will be only and only paying for one cluster. Now, one major thing you need to understand, always and always choose the size of the warehouse by keeping one thing in your mind, that you need not only just the performance, but you also need to save the cost. So always make sure to choose this virtual warehouse size where you find a perfect balance between the cost and the performance. What does it mean? Okay, so that I mean by this, what's wrong with this? Okay, so let's suppose there is I'm taking a small warehouse, and I executed one query, this complex query. This is my complex query, okay, which is taking the data, which is reading the data from a big table which is having 100 or 500 GB of data, and in fact terabyte of data, and then you are performing some aggregation. So this one complex query took 2 hours, let's suppose. This is terabyte of data, and it's a hypothetical situation, so don't just get why this Snowflake is then taking 2 hours. Okay, again a hypothetical situation, the terabyte of data, you're performing aggregation, and the join got exploded, so that's why it is taking too much time. Okay, so it is taking 2 hours. Now for the 2 hour of the query, for this complete query, the rough calculation, you will be paying how many, for this one, come back to here, for 2 credit per hour. So that means for 2 into 2, 4 credits, and we are using our enterprise edition. So ultimately we will be paying $12 for this particular query, right? But you are paying $12, but it is taking 2 hours. While the business owner is saying, no, I cannot wait for this 2 hours. You were using that complex query in your Tableau or in Click or a Power BI, you definitely cannot wait for the 2 hours. So then you will be trying to go like, okay, why should I not go for small to large? Let's suppose, like if I'm going for this large warehouse, and for the same query, I go for this one complex query, because in small we were having 2 people, that took a 2 hour, but in large we have 8 people, right? We have 8 people, which is almost going to 1/4 of it, means almost 30 minutes. Let's suppose it is going to take 30 minutes. But in this 30-minute, large, how much it took? Large takes 68 credit per hour. Okay, large take 8 credit per hour. So it is going to take 4 credits because it took 30 minutes, and that also going to take $12 for that query. Now, which one we are going to choose? We need a perfect balance between the cost and the time. If I'm going to use this small warehouse, I need to pay $12, but I will be waiting for 2 hours. While if I'm going for large warehouse, I'm also paying $12 for the large warehouse, but it is only and only computing that process or completing that query just in 30 minutes. So that's how this is one thing we're gonna consider in our mind to choose the size of the warehouse. Okay, sounds good. I hope yes, you will be getting it. So this is we're gonna learn about it. However, the sum of the terms which you need to go through, I will be pasting my link of the blog: scale up, scale out, warehouse size, recommendations, and some parameters. Okay, this is now if you're going to run and show warehouses, you will be finding some other parameters also. Okay, this is going to be okay, we have created this YouTube learning warehouses. You can see which is the state, size, minimum cluster count, max cluster count, started clusters, their running, queued, auto suspend time, auto resume time, available, created on, resumed on, and you will be seeing some other things also, like it's an enable query exclamation, that is definitely not. And then this is a failed, suspended, how many queries is when you have suspended it, scaling policies, which is standard or economy. You will be seeing all these things over here. However, there are few other properties which you need to explore and tell me in the comments. What if my query, what if I'm going to execute some queries, but there are I wanted to give a certain limit of the statement which can be queued only. Then which properties I will be writing, or if I am going to execute one of my query and I do not want that should wait for 1 hour or 2 hour, then which property I will be setting up. So you just need to check it out for these two property which is related to the virtual warehouse, and you need to answer it into the comment section, and I will be discussing if there will be anything in my next video. So that's it for today. I hope you had a good understanding of the virtual warehouse. Feel free to drop your comments. Feel free to ask anything which is not clear. And thank you. Thank you. And please subscribe this channel for the upcoming videos to make your learning very smooth. Have a good day.